Hi guys, welcome to your first virtual practical. Practical 1 is going to be a chromatographic practical. So we're going to go through experiment 1 first, which is to determine a mixture of unknown amino acids. So I'll go through the equipment and apparatus quickly. We've got our amino acids here, developing chamber with a lid, our capillary tubes, funnel, measuring cylinder, the eluent we need, ninhydrin, stapler, and you'll need a ruler and pencil as well. And we have a chromatographic paper. So the first thing that you need to do is to put the eluent into your developing chamber. The reason this is the first step is because you want the atmosphere in the developing chamber to be saturated by the time that you develop your chromatogram. So about 20 milliliters. It's an estimate, so we don't need to be too accurate. Of our eluent, that is a methanol water mixture. Pour that into your developing chamber, cover with the lid, and just set aside while you do the rest of your preparation. Okay, I have already prepared the paper chromatogram as is outlined in your instruction sheet. So we have a line 1.5 centimeters from the bottom, and you'll see I've made a mark for the different amino acids as well as unknown 1. We're going to go through all the unknowns. We'll show you the developed chromatograms at the end, but for this video, I'm just going to use unknown 1. Okay, so what you're going to do is you need to use a capillary tube. When you use a capillary tube, you need to make sure that when you spot your amino acid, you hold the capillary tube straight up and down, because if you hold it at an angle, when the amino acid comes out, it's going to spread, which is going to make it harder for you to determine the RF value, and it may also spread into one of the spots next to it. Okay, so we're going to start with asparagine. Simply dip it in, take it over to our asparagine spot, and just tap it down. Wait for it to dry and give it about 2 or 3 more spots. Okay, we're going to use a new capillary tube for the cysteine to avoid cross-contamination. Same method, we're going to spot 3 or 4 times, wait for it to dry between each spot, so that you rather get a concentrated spot than a diluted large spot. This will be repeated with glycine. Our unknown, which is unknown 1. Unknown 1 is a mixture of 2 of the known amino acids. Move over to histidine. We repeat with isoleucine. And finally with proline. Okay, so now that we've spotted all of our amino acids, we're just going to wait for them to dry. So you'll see, you can kind of see it's still a little bit wet here by the proline perhaps. We're going to take a stapler, roll it around so that the spotted side is on the outside, and we're going to staple it into a cylinder. So with this, you want to try and touch the paper chromatogram in as few places as possible, especially if you aren't wearing gloves, because you have amino acids on your hands which could react. Just to the side. So the safest place to touch your paper chromatogram is going to be near the top, because remember, we're going to use the eluent front, so wherever the eluent comes up to, we need to remember to mark that line. Anything above that we won't be using. Okay, so our developing chamber should have a saturated atmosphere by now. So what we're going to do is place our paper chromatogram into the developing chamber, making sure it doesn't touch any of the sides. We're going to close it and allow it to develop. You will see the solvent front moving up the paper chromatogram. Okay, so what happens here is we have a stationary phase, which in this case is a cellulose in the paper, and the mobile phase is our eluent, our methanol water mix. So what happens is each amino acid has a different affinity for either the stationary phase or the mobile phase. So it will spend either more time in the stationary phase on the paper or in the mobile phase, which is the eluent. So as the eluent rolls up the paper chromatogram, your amino acids are going to change from being dissolved in the paper chromatogram to being dissolved in the eluent. And this is how that they are brought up along the paper chromatogram, which you will see at a later stage. Okay, so you can see the solvent front has moved up. So the first thing we need to do when we take it out of the chamber is mark with a pencil about 2 or 3 marks where the solvent front is, because this is what you need to determine your RF value. So we can just rip out the staples, because that's not a very important part of the chromatogram, and we lay it face up on the desk and we wait for it to dry. Keep our lid closed for our eluent. I'll be using it later for the other paper chromatograms, but you need to discard it into your organic waste once you are done with it. So we're just going to wait for the chromatographic paper to dry off. Okay, so the eluent has evaporated off our paper chromatogram. So we're just going to place it on tissue paper and spray it with ninhydrin. Okay, then we're going to leave it for a few minutes to evaporate slightly, and then we're going to heat it over a Bunsen burner, and then the heat from the Bunsen burner will react with the ninhydrin and the amino acids, and we will be able to see where they have, how they have traveled.